Hey everyone! So, if you're building on AWS, you probably know how this goes. You start with a few virtual networks, everything's clean and simple. But as you succeed and grow, that handful of VPCs can explode into hundreds. Suddenly, you're looking at this complex web, and you're wondering, how do I manage this? How do I secure it? Well, today we're going to dive right into the official AWS white paper to find out the best way to tame that complexity and build a network that's ready for some serious scale.
So here's the game plan. First, we'll get a handle on why this scaling thing is such a challenge in the first place. Then, we'll start solving the puzzle of how to connect all those networks. After that, we'll look at building a bridge to your on-premises data centers, then centralizing your security, and finally, we'll put the finishing touches on with DNS and service endpoints.
And this quote from the white paper really gets to the heart of it. Growth is a great thing, right? But every new team, every new app, heck, every new dev environment often gets its own little sandbox, its own VPC. And that's fantastic for keeping things isolated and organized at first. But it doesn't take long before your once tidy network map starts to look a little chaotic.
And this image, well, it paints a pretty clear picture of that growth. You start out simple, but before you know it, you've got these organizational units for production, for staging, for different business lines, and each of those can have multiple AWS accounts, and each of those can have multiple VPCs. And that is the sprawl we need to get under control.
Okay, so that brings us to our first big question. We have all of these isolated virtual clouds. How in the world do we get them to talk to each other when they need to without creating a complete mess?
Well, the first tool you might reach for is VPC peering. The concept is super simple. Think of it like building a private, secure bridge directly between two VPCs. It's point-to-point, it works great, and honestly, for just a handful of connections, it's perfect.
But, and this is a big but, what happens when you have dozens or even hundreds of VPCs? This slide just illustrates the problem so well. You end up with what's called a full mesh. It's a spiderweb of individual connections. Every time you add a new VPC, you have to go and build a new bridge to every single other VPC it needs to talk to. You can see how this gets complicated and fast.
And if that visual wasn't enough, here's a number to really drive it home. To fully connect just 100 VPCs, you would need to create and then manage 4,950 separate peering connections. Yeah, that's not just unmanageable, it's a non-starter.
So you have to be thinking, come on, there has to be a better way to do this. And you'd be right, there absolutely is.
And here it is, AWS Transit Gateway. This thing is a game changer. Instead of that messy point-to-point mesh, Transit Gateway gives you this beautiful, clean hub-and-spoke model. It's like a central airport for your network. Each VPC just builds one connection to the hub, and the Transit Gateway acts as a cloud router, handling all the traffic between them. It's so much simpler and it scales like a dream.
Okay, so we've sorted out how to connect all our VPCs in the cloud. That's a huge step. But let's be real, most of us don't live in a cloud-only world. The next piece of this puzzle is connecting AWS back to our own physical data centers.
And for that, the gold standard is AWS Direct Connect. Now, this is not just a VPN running over the public internet. No, this is a dedicated, private fiber optic cable running straight from your building into the AWS global network. It's way more reliable, you get much higher bandwidth, and just a far more consistent experience overall.
And check this out. This shows how Direct Connect has gotten even better with a feature called Site Link. So look at the before picture. If you had two different data centers and you wanted them to talk to each other, the traffic had to go all the way into an AWS region and then back out. Kind of inefficient. But now with SiteLink, you can flip a switch and bam! They can talk directly to each other right over that AWS global backbone. It's faster, it's cleaner, and it's a huge deal for hybrid networking. All right, so now we've built this amazing, highly connected network. It spans our cloud VPCs, it connects to our on-prem data centers. It's awesome for getting work done. But it also opens up a new question. How do we actually inspect and secure all this traffic in a consistent, manageable way?
So, the first move is to control how all your VPCs talk to the outside world, to the public internet. The best practice here is to not give every VPC its own door to the internet. Instead, you funnel all of that outbound traffic through a single, specialized egress VPC. It uses a NAT gateway to manage all the traffic, giving you one single choke point to monitor and secure everything going out.
And we can take that one step further. We can actually insert the AWS network firewall right into that same egress VPC. So now, the traffic flows from all our different VPCs, hits the transit gateway, which routes it over to the firewall for some deep packet inspection, and only then, once it's been cleared, does it get to go out to the internet. This gives us a centralized, powerful firewall for our entire cloud network.
Now, as you're setting this up, there are a few really important things to keep in mind. First, always deploy your firewalls across multiple availability zones. You need that high availability. Second, remember that this thing is built to scale. It can handle a ton of traffic, and if you're in a big organization, you absolutely want to be using AWS Firewall Manager. It lets you write your security rules once and then push them out everywhere, consistently.
All right, we're on to our final section. We've tackled connectivity and security, which are the big, heavy lifting parts. But now we need to talk about the final polish, the operational details like DNS and service endpoints that make a huge network actually manageable and cost-effective.
So let's talk about hybrid DNS. When your applications are spread out between your own data center and the cloud, you need them to be able to find each other using their names. Hybrid DNS is the solution that bridges the gap, allowing your on-prem servers to find your cloud servers and vice versa, just like they were all in the same room. It makes everything seamless.
And are you sensing a theme here? Because just like with security, the key is centralization. You do not need to set up this DNS bridge in every single one of your VPCs. Instead, the smart move is to create these Route 53 resolver endpoints in one central networking VPC and then share them out to your entire organization. It's cheaper and it's just way easier to manage.
And this same logic applies to how you access AWS services like S3 or DynamoDB from within your VPCs. Instead of creating a separate, costly VPC endpoint in every single VPC, you can centralize them in that same shared services VPC. Then, everyone can access them securely through the transit gateway.
So if there's one single idea that runs through this entire white paper, it's this right here. Whether you're talking about routing, security, DNS, or service access, centralizing these network functions is what simplifies management, cuts your operational costs, and gives you that consistent security posture you need at scale.
And that's our tour through building a scalable and secure multi-VPC network. The principles we talked about, that hub-and-spoke model, and of course centralization, are really powerful tools for fighting back against complexity. So the question I'll leave you with is this. You know your cloud footprint is only going to get bigger. Is your network architecture truly ready for it?